Yes. Okay. Everything is good. We are connected in YouTube. Very nice. Students, everyone has to answer it. Please answer. Everyone who has joined the session, please let me know. Whoever has joined the session, please answer the technical check. Yes. Okay. Good. Okay. Nice. So, students, welcome to today's class. My name is Samanmeet, your physics faculty from Avantifellows. Good evening, Abhay. How are you? Please answer the technical check. Okay, as I can see, most of you have answered. And as I can see, there is no issues in my audio or my video. Okay, good. Abhay, thank you. I'm ending the poll. Okay, I'm ending the poll. Yes, good. Very nice. Now, yeah, very nice. So, students, how's the weekend? Or okay, you had the weekend, and yesterday you had a holiday, right? So there was no YouTube, there was no class. Did you enjoy it? Harshada, Ballari students, yes, Pass VT, Yadgiri students, welcome to today's class. Okay, nice. And students who are joining from YouTube Live, good evening. Good evening. Yes. Acha. Okay, Chitraduga students, very nice. Okay. So students, we were talking about what, as you can remember, I hope you remember the class also, what work, power, energy, right? Work, energy, and power. Right now we are talking about work. Now let's say from today's class we are going towards energy. Okay, we'll be talking about energy from these, let's say from tomorrow's class, or by the end of the class will have a touch of it. Okay, so we have already covered a lot of things about work. Okay, so before going ahead, let me take a quick, let's say, contents of today's session, what we are going to cover. Okay, first thing is quick recall. Okay, what we have talked about in the last class, or day before yesterday's class, or last week class, such that today, since from yesterday we let's say from Monday we were solving numericals. Yes, we talked about numericals. Yes, so I hope you will be able to solve the numericals more easily, such that we'll go through the like contents of what we have studied. Okay, then there's a numerical. This is basically to basically understand whether you are reading or not. It is for me. Okay, then we'll be talking about basically potential energy. Yes, we'll be talking about potential energy. Then we'll be going the conceptual questions of potential energy. As I said, we have talked about work already. Now we are diving into something called energy. Today we'll be talking about potential energy. Okay, and also in the previous classes we have tried to connect what work done with what kinetic energy. Yes or no? Do you remember this? Yes or no, students? Let me know in the chat. Let me know in the chat. Yes or no? Have you connected work and kinetic energy? Students, yes. Okay, very good. Very nice. Yes, everyone, very good. Okay, yes, Suman, very good. JNV students, you need to have a constant interaction. Okay, ಇಲ್ಲತ್ತಿದ್ರೆ ನಂಗೆ ಅರ್ಥ ಆಗಲ್ಲ, ನಿಮಗೆ ಅರ್ಥ ಆಗ್ತಿದೆಯಾ ಅಂತ ಪ್ಲೀಸ್. ಓಕೆ, ಯಾದಗಿರಿ ಅಂಡ್ ಬಳ್ಳಾರಿ ಸ್ಟೂಡೆಂಟ್ಸ್ ಸ್ವಲ್ಪ ನಿಮ್ದು ರಿಪ್ಲೈ ಬರೋದು ಕಮ್ಮಿ. ಪ್ಲೀಸ್ make sure if there is anyone to help you, please tell them to make sure that there is thumbs up or anything. Okay, then we'll be talking about gravitational potential energy. Over here we are not going to dive deep into it. I'll tell you why. Because do you remember there is a chapter called gravitation? Do you know there is a, in class 11 there is a chapter called gravitation? Yes or no? Okay, very nice. In gravitation we'll be talking about the potential energy of gravitation. Okay, so here we'll be talking about just the formula, but in what, in let's say gravitation chapter we'll be going deep dive. Okay, we'll be like basically diving. जो स्विमिंग पूल होता है ना, हम डाइव कर लेते हैं उसके अंदर. ठीक है, now that is the case students. Let's begin with the quick recall from the starting of work, power, and energy. Yes, so see, initially we were talking about work done as what students, in your, let's say, 9th 10th class, you know that it was force into displacement. Yes, over here, since you are in 11th class, we had to talk about work in terms of what dot product, and it was F dot S. Yes or no? And we came to know that work done is what? Fs cos theta. Yes or no? Where we saw that if there is a body and if you're applying a force and the displacement is happening in the direction of force applying. So I'm vaguely telling so as that you remember all these things. Then what did we talk about, students? Do you remember what did we talk about? Yes. Then we talked about the work energy theorem, where we saw that we tried to what relate with work energy theorem. So what does work energy theorem says? Yes or no, students? Can anyone tell what does the work energy theorem say? Yes, work energy theorem. Yes or no, students? Let me know. What did we talk about? Let me know in the chat. Okay. Yes, very good. Yeah, very good. So what was it? The work done by all forces, basically. Work done by all forces is equal to change in kinetic energy. Yes, very good. So this is basically what kinetic energy final minus kinetic energy initial. Yes or no? And also we saw that, see, for a, okay, before this, we also saw that work done for, we also saw work done for, work done by, work done by variable force. Yes, variable force. Yes or no, students? Over here, we saw that this F is what? A, a constant force. Yes or no? A constant force. It doesn't vary. Yes. After this, we basically talked about other thing also. One thing is conservative force. We talk about conservative force and a non-conservative force. Non-conservative force. Do you remember what is a conservative force and a non-conservative force? We are going quickly through all these things so that you remember this. Yes. What is a conservative and a non-conservative force? I want Yadgiri students to tell. Yes, Chitraduga students, very good. Yadgiri students, what is a conservative force? Very good, very good. Yadgiri students, can you tell me? And Davangere students, very good. Others, very good. So what was happening in conservative force? If there is a path from A to B, it doesn't matter which path you took. Yes, it doesn't matter which path you took. Let's say path one. Yes, very good, very good. This is path two. The Chitradurga students, very good. Non-conservative also. Very good, very nice. This is third. Yes. Here you came to know that work done by first, work done by second, work done by third are equal. In what? In conservative force. And in non-conservative force, was that what was it happening? We came to know that it was depending on the path. It was depending on the path. And here it was what? Independent of path. Independent of path. Yes. Yes or no? Yes, very good. It was the two basic things that we were talking about. Yes. Here we came to know that the work done by first path is not equal to work done by the second path. These were the things we talked about. Yes. And also we talked about work done by variable force. We came to know that work done can be represented as what? Integration of F dot what? R. Yes or no? Yes or no? Where we told that if it is only in X direction, it was what? Work done is integration of F dot dx. Only if it is y direction, what is it? If it is only y direction, work done is integration of F dot dy. I'm doing this because since we are solving numericals, you need to remember all these things. Okay. Z direction, it was what, students? Work done is F dot dz. Now, if the work done is in all direction, then the work done was what? Integration of f x dx. Yes, this is fx, fy, fz, fx dx plus fy dy plus fz dz. Yes. Yes or no, students? I hope you remember this. Let me know in the chat. Let me know. Very good, very good. Let me know, students. Nice, very good. Okay, Davangere students, let me know. Is there any doubt? Is there any doubt? Okay, very good, Arshada. Very nice, very nice. Now, I hope you remember all these things. Yes. Now, if that is the case, students, here is a quick question for you. The question says, if the work done by the forces is independent of the path and depends only on the forces of initial and final position. This is very easy. Initial and final position on the path. That force is known as what? That force is known as, very good. Others. Very good. Ballari students, let me know in the chat. Madhya. Ballari students, ಏನಾಯ್ತು? All good? Ballari students, okay, very good. Yes. Parth, check your answer. Check your answer. Abhay, check your answer. What is happening over here? Work done of the forces is independent of the path. Davangere students, you need to check your answers. Abhay, very good. What? It is the force. It is independent of the path and depends only on the forces of initial and final position. Agar initial and final position hai, it is independent of the path. Yes, whatever the path you take, it is independent. Very good, very good. So the right answer is what? It is a conservative force. Yes, very good. Yes. Ha. So make sure that you read your questions very easily. Okay, very properly. Yes, Davangere students, why did you make a mistake initially? Let me know. Let me know in the chat. Why did you make a mistake initially? Yes, very good. Now, if that is the case, students, let us quickly go to the numericals. And I can remember that I have given a, let's say, a Homo question also. Yes? Yes or no? Have you done it? If that is the case, let us start with that Homo question. If you have solved it, then it's very good. Now, the question says, a ball of mass m is dropped vertically through a height of 20 meter and it gains a speed of 10 meter per second after 20 meter. Okay. So what is happening? Over here, let's say there is a height of 20 meter. Okay. ये 20 meter height है. From here, there is a ball. There is a ball. Okay. There is a ball of what? 5 kg mass. It is dropped and it gains a speed of what 10 meter per second after 20 meter. मान लो यहाँ आ गया 5 kg. It gains a speed of what 10 meter per second. तो ये बताओ कि work done by gravitational force and air friction क्या होगा? Okay. So what you want gravitational force and air friction का जो work done है वो क्या होगा ये बताओ. Okay. So I'm giving you exactly 3 minutes of time, students. ये बहुत easy है. Please try it. I'm exactly giving you 3 minutes of time. Please solve this question, students. Please try to solve this and let me know what is the answer for this. Okay. Sorry, ये 3 second है. 3 second बहुत कम है ना? Yes. Let me know. Harish, Sudarshan, very good, very nice. So please answer the question. Okay. Okay, you got the answer. Yes, Sudarshan, that is very good. But Sudarshan, it is for what? The answer you got. Let me know. And others, let me know in the chat. Let me know. The time is running. Okay. Sudarshan, let me know. Chitradurga students, that's not the right answer. Check your answer. Check your answer. Check your answer. Parth, check your answer. Yes, very good, Parth. That is what? That is the answer for what? Which work done? Last 40 seconds. Abhay, check your answer. Check your answer. Chitradurga, Davangere, North Canada students, let me know. Yadgiri, okay, North North Canada students joining after a long time. How are you all? ಹೇಗಿದ್ದೀರಾ? How are you all? Yes. Okay. Last 16-15 seconds. I'm waiting here. I'm waiting for your answers. Yes. Okay. Time up, students. So should I solve it? Let me know. Someone, no, that is not the right answer. Now, let us try to solve this. See, the question says over here there is a 20-meter height. Okay, there is a 20-meter height. I have a 5 kg mass. Now, what will I do is I'll take this 5 kg mass and I'm going to drop this 5 kg mass. Yes. Now they're saying that a ball of 5 kg mass is dropped from vertically through a height of 20-meter. Yes, that is true. And it gains a speed of 10 meter per second after 20 meter. So can I say this 5 kg mass has an initial velocity 0 and the final velocity has 10 meter per second after 20 meter? Yes or no, students? Let me know in the chat. Let me know in the chat. Just a second, students. Yes or no, students? Let me know. Let me know in the chat. Yes, very good. Now, over here, you know that gravitational force is acting along this direction, mg. Yes. Yes or no, students? Yes or no? Yeah. And also, you know that the displacement is happening what downwards. What? See, mg इधर है, displacement भी इधर है. आपको पता है work done क्या है? Work done by gravitation force can be written as what? Fs cos theta. Cos theta क्या है? 0 है. Theta 0 है. Yes or no? Because F and S are in the same direction. Yes or no? And you know that F is what? M into G. And theta is 0. If theta is 0, cos theta is 0, 1. And displacement is happening for how many? 20 meter, 20. Now, students, can I write what is M? 5. G, let me take G as 10 meter per second square. Yes. So, what is G? 10 into 20. Yes or no? Now, students, very good, very good. Now, what is 5 into 5 is 50. 50 into 20 is what? What, students? What will we get? We'll get 200 into 5. That is 1000 joules. Yes or no? This is the work done by gravitational force. Very good. Yadgiri students. Very good. I guess you are talking about air resistance. Yes. Now, मुझे ये बताओ, अगर मैं इसको गिराऊंगा यहाँ से, एक बॉल है, ठीक है, 5 kg, तो there will be some air resistance. Yes or no? अच्छा, ओके भाई, देखो, एक बॉल था इधर, ठीक है, तो मैंने क्या किया, उसको वहां से गिराया, ठीक, ऊपर से. अगर मैं उसको गिराऊंगा तो उसका इनिशियल वेलोसिटी 0 होगा, है कि नहीं? और उन्होंने बोला कि उसका वेलोसिटी 10 मीटर पर सेकंड होगा 20 मीटर के बाद, वो फाइनल वेलोसिटी होगा. सही है. अब मुझे बताओ, इसका अगर एफबीडी बनाऊंगा तो आपको पता है ये 5 kg मास है, इसका ग्रेविटी जो फोर्स है क्या है? ग्रेविटेशनल फोर्स है. और आपको पता है कि जो डिस्प्लेसमेंट हो रहा है एस, वो इस तरफ हो रहा है, वो डिस्प्लेसमेंट क्या है 10 है, सॉरी 20 मीटर है, 20 मीटर है कि नहीं? अब मुझे बताओ, वर्क डन इज इक्वल टू एफ एस कॉस थीटा. आपको पता है? ये बताओ, फोर्स और डिस्प्लेसमेंट के बीच में जो एंगल है वो क्या है? वो है 0. थीटा इज इक्वल टू 0 डिग्री. तो क्या होगा? वर्क डन एफ एस होगा ना. तो आपको पता है एफ क्या है? एफ इज एम जी. यस. एस इज व्हाट? डिस्प्लेसमेंट, दैट इज 20. तो मैंने उसको ही यहाँ अप्लाई किया. यस. इज इट गुड? वेरी गुड. now talking about the, okay, this is solution. Okay, solution. Talking about work done by air resistance. ये कैसे find out कर सकते हैं? How do you find out? In order to find out that, we have the equation work done by gravity plus work done by air resistance is equal to what? Work done by all forces is equal to what? Change in kinetic energy, that is kinetic energy final minus kinetic energy initial. Yes or no? We know that V initial is 0, V final is what? 10. Yes or no? 10 meter per second. Now, can I put gravitation? We got 1000. Yes or no? We got at 1000. Yes or no, students? Plus air resistance हमें चाहिए. वो हमें, that is the answer that we want. Kinetic energy is what? Half m is what, students? What is the mass? Pi. I'll take it as common. V square, that is V final square is 10 square minus V initial square is 0. Yes. And we get what, students? Work done by A resistance equal to what? Half into 5 into 10 square is 100 minus 1000. Yes. And work done by A resistance is what? 500 by 2 is 250 minus 1000, and we get A resistance at what? Minus 750 joules. Yes. This is your answer, students. Did you get it? This is your answer. Let me know in the chat, students, were you able to understand this or not? Yes, very good. Others, let me know. Yadgiri students, North Country students, Parth, PT, Krishna. Okay. Acha bhai. Okay. Yes. Okay. Krishna, I'll answer you. See, Krishna, आपको ये पता चला कि ये कैसे फाइंड आउट किया ग्रेविटेशनल फोर्स का? Yes or no? Krishna, let me know. Yes or no, Krishna? Let me know. Yes. Okay. I'm assuming that you understood this. Now, see over here you wanted what? Air resistance का, ठीक है? लेकिन इसको कैसे फाइंड आउट कर सकते हैं? आपको पता है एक फॉर्मूला, वर्क डन बाय ऑल फोर्सेस, कौन सा? वर्क डन बाय ऑल फोर्सेस इज इक्वल टू व्हाट? चेंज इन काइनेटिक एनर्जी, है कि नहीं? कृष्णा, लेट मी नो. कृष्णा, यस, वेरी गुड. तो मैं ये लिख सकता हूँ ना, ग्रेविटेशनल फोर्स प्लस वर्क एयर रेजिस्टेंस इज इक्वल टू व्हाट? काइनेटिक एनर्जी इनिशियल माइनस काइनेटिक एनर्जी फाइनल, इस फॉर्मूला से. एंड आपको पता है कि काइनेटिक एनर्जी इज व्हाट? हाफ एम वी स्क्वायर. तो मैं इसको ऐसा भी लिख सकता हूँ ना, इसको हाफ एम वी क्या? फाइनल स्क्वायर माइनस वी इनिशियल स्क्वायर. तो आपको पता है कि इनिशियल वेलोसिटी 0 है, फाइनल वेलोसिटी 10 है, यहाँ पुट कर दिया. फिर आपको पता है चला हाफ एम व्हाट? हाफ. ओके, ओवर हियर. यस, देखो ये 0 आया, अगर ये 0 है तो ये कैंसिल हो जाएगा, ये तो 0 ही हो जाएगा. ओके, जस्ट अ सेकंड. यस, ये वाला 0 हो जाएगा. मैं इसको इस लेफ्ट साइड लेकर आया तो ये बचा और माइनस 1000 हो गया. यस और नो? ये माइनस 1000 हो गया. देन इट विल बी व्हाट? 2 1s are 2 what? 50s are 5 5s are 250, 250 minus 1000, that is 750 joules. Yes or no? अभी तक समझ में आया? Very good. Krishna, let me know in the chat. Harish, very good, very nice. Yes, okay, very nice. Abhay, very good. सबको समझ में आया? If that is the case, clear? Okay, very good. Then let us jump into another question now. If that is the case. Now, the question says, a force F equal to 2 into I cap plus 3 into J cap, okay, acts on a body to displace it from 1 to 2 to 4 to 1. ठीक है? यहाँ से यहाँ तक. If the initial velocity of the body is 2 meter per second, that is V initial is 2 meter per second and mass is 10 kg, उनको चाहिए क्या? फाइनल वेलोसिटी. इनको चाहिए फाइनल वेलोसिटी. देखो ये सॉल्व करने के लिए I'll give a hint for you guys. Do you remember we had done something called work done is equal to fx dx plus work done equal to plus fy dy. ये क्या है? ये क्या है? याद है? Let me know in the chat. ये याद है? याद है कि नहीं है? बताओ. Let me know. Yes. हाँ, वहां हमने क्या किया था? एक लिमिट भी लगाया था x1 to x2 and क्या? x let's say sorry y1 to y2, है कि नहीं? Now apply this and you know that work done is what? Change in kinetic energy, जो भी total work done है. फिर आपको पता चलेगा कि v फाइनल क्या है. ठीक है? क्या स्टेप है? पहले ये फाइंड आउट करो, फिर यहाँ इसको इक्वेट करो, सेकंड स्टेप, then try to find the final velocity. I give the hint. Please try to solve this, students. I'm giving you exactly 3 minutes again. Please try to solve this. Okay? Okay, the time is running. Please let me know what is the final velocity. Yes, everyone has to answer. Okay. So here is the thing. Here is the deal. Okay. If you answer correctly this, I'll make sure that whenever we meet next time, I'll treat you guys. Whoever answers it correctly. Okay. So take your time, answer it very, very correctly. Okay. 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 I have to off the lights. Okay. For a while. So I'm offing the light. So please answer the question, students. Acha, acha, acha. Okay, okay, okay. Yes. Bye. Sorry. Yes, students, please answer. What is the answer for it? ये बहुत easy है. What is the answer, students? Okay, Chitralgo students has given the answer. Students, check your answer once. Check your answer once. पक्का वो है. Yes, Chitralgo students, very good. So next time ನಾನು ನಿಮ್ಮನ್ನ ಮೀಟ್ ಆಗಿದಾಗ ಪಕ್ಕಾ ಯಾರೆಲ್ಲ ಆನ್ಸರ್ ಸರಿ ಮಾಡಿದ್ದಾರೆ I'm going to give a treat, okay? Or do one thing, is there any Avanti faculty over there? Ask treat with them. Okay. Yes, very good, students. YouTube live students, please answer it. Chitraduga students, who is over there? Let me know. Let me know. Let me know. Who is over there? Any Avanti faculty? Okay. Did you divide it? Okay. Acha. Okay. 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 Whichever ma'am is over there, you can ask for treat. Okay. From my side, just think that it's me who is giving you. Okay. So students, time is up. We are going to solve it now. Okay. How to solve this? Students, as I said, over here, just remember students, over here, there are two things that is given. Okay. They have given the force to be, they have given the force to be what? What students? 2 into I cap plus 3 into J cap. Yes, yes, Parth. Yes. Yes. So if you have divided it, then it is, did you get the answer as 223 by 5? Then did you divide it? Okay. So yes, very good path. Very nice. So the force is given over here. Okay. So from here, you know that Fx is 2 and Fy is 3. Yes or no? And also it is given that there is this limit that is given from 1 to 2 and 4 to 1. So from 1 to 2 and 4 to 1. Yes, Path, whenever we meet, I'll be giving you treat. Don't worry, okay? Hopefully we'll meet someday. Yeah. Okay. So here is the limit that is given. Students, you know that you have a formula for work done, that is integration of f dot dr. Yes. And also you know that work done is from what? If that is the case, if 2 fx and fy is given, we can write as fx dx plus integration of fy dy. And over here, you know that this is x1, this is x2, this is y1, and this is y2. Can I write the limit as 1 to 4 and 2 to 1? Yes or no, students? Let me know. Yes or no? Let me know, students. यहाँ तक सही है? यहाँ तक सब ठीक है? Now, students, now if I solve this integration, I'll get work done as integration of 1 to 4 2 dx plus what? 2 to 1 3 dy. है कि नहीं? That is what I got. Yes, fx is what, 2, and this is 3. Yes, and if I solve this, I'll get what, 2x 1 to 4 plus 3y 2 to 1. So will I get this as 8 minus 4, 8 minus, sorry, 8 minus 2 plus what, 3 minus 6, and I'll get what, 6 minus 3, and will I get the work done as 3? Yes or no, students? Yes. Now what you need to do is, you have another formula. The work done by all forces is equal to what? Kinetic energy initial minus, sorry, final minus kinetic energy initial. Now students, you have work done by all forces is what? What? You get it as 3, which is equal to half m क्या आया, final velocity square minus initial velocity square. We want final velocity square. You know that initial velocity is how much? Initial velocity is 2 meter per second, and the mass is 10 kg. So can I put over here 3 into 2? मैं इसको यहाँ लाया, which is equal to what? Mass is 10, and Vf square minus what is initial, that is 2, that is 4, that will become 2 square. Will I get 6 by 10 equal to what, students? Vf square minus 4, and Vf square comes out to be, what is it? 2 1 2 3s are 2 5s are, so 3 by 5 plus 4, which is basically equal to what? 23 by 5, and Vf I'll get as root of 23 by 5 meter per second. This was your answer, students. Yes or no? Let me know. This is your answer. Let me know, students. Did you get it or not? Yes or no? YouTube live students, let me know. Every JNV students who is present over here, let me know. Very good, very good. Others. Sweetie, क्या हुआ? अच्छा वैसे, हाँ तो एक काम कर लो, प्रैक्टिस कर लो, ठीक है? Try practicing the problems. Okay, very good. North Canada students, are you present? Let me know. Are you able to understand or not? Yes, Parth, Abhay, Arshada, Suman. Okay, North Canada students. See, over here, I'll explain it again. See, over here, it is given that force is what? 2x, 2i cap plus 3j cap. So basically, they're telling this is fx, this is fy. Yes. And also they have given a limit from 1 to 2 to 4 to 1. Yes. You know, there is a formula that is what? Work done is equal to force into dr, or let's say, no, I won't confuse you. Force into r, and that is integration. This is the formula you have. Yes. Now, students, you know that you can write this as what? You can write this as in terms of fx dx plus fy dy using the limit. Yes. And I told you this is what? X1, this is x2, and this is y1, this is y2. Now, if that is the case, I can write work done as what? This. Yes or no? North Canada students, let me know. ಹೌದಲ್ವಾ? ಹೀಗೆ ಬರಿಬೋದಾ? ಲಿಮಿಟ್ ಆದ್ರೆ ಹೀಗೆ ನೋಡ್ಬೋದಾ? ನೀವು ವರ್ಕ್ ಎನರ್ಜಿ ಥಿಯರಮ್ ಇದ್ರ ನಾರ್ತ್ ಕನ್ನಡ ಸ್ಟೂಡೆಂಟ್ಸ್, ವೆರಿ ಪ್ರೆಸೆಂಟ್ ಇನ್ ನಾರ್ತ್ ಫಾರ್ ವರ್ಕ್ ಎನರ್ಜಿ ಥಿಯರಮ್? Yes or no? Yes or no, students? Let me know. Okay. North Canada students, please reply. Were you present for work and okay. So yeah, using the work energy theorem, students, see, make sure that you go through that and check the theorem over here. Okay. From there we have solved this. Okay. ಇಲ್ಲಿಗೆ ನಾವು ಬಂದಿದ್ದೇವೆ. ಓಕೆನಾ? ಇದು ನಿಮಗೆ ಗೊತ್ತಿರಬೇಕು. Now what we did was we solved this using integration. You applied integration, you got work done as equal to 3. This is the steps you need to do. Okay. So before understanding this problem, you have to understand work energy theorem. Yes. Then only you will be able to understand this theorem. Okay. So go to the YouTube, you'll get the lesson. Please go through that. Okay. And using the work energy theorem, we get that work done by all forces is what? Kinetic energy final minus kinetic energy initial. Using that formula, we got the what the final velocity as root 23 by 5. Okay, so go through the previous class. If you are not able to understand this, then we'll be going through again. Okay, I'll make sure that you'll understand it again. Yes, is it good? Very good, very nice student, very nice. So if that is the case, students, now we are going into what the topic, that is potential energy. Now what is this potential energy, students? Can anyone tell me what is this potential energy? Can anyone tell me? Acha. Okay, Davangere students, good. But yeah, okay, stored energy in an object, very nice, very good. Stored energy, okay. See, the thing is, in physics, when you talk about physics, in physics, potential energy is not defined. Okay, the potential energy is not defined in physics. Basically, in physics, what is defined is in physics, the definition is given in terms of what, students? Change in potential energy. Hey ki nahi? Change in potential energy. Most of the time, whenever you see over there, whenever you see over here, there is no definition of what defined as a potential energy. What they do is they tell that potential energy is what? Basically they tell that in terms of change in potential energy. Did you get it, students? Yes or no? Now whenever you go to the definition of potential energy, you see that change in potential energy. Do you remember the formula, students? Let me know. Can anyone tell me what is the formula for change in potential energy? Change in potential energy is equal to, do you know, students? Let me know in the chat. Do you know? No. That is not the formula. That is for a specific case, student. That is for a specific case. I know what you're going to do, what you're telling, but Adu, it's for a specific case. Okay. Okay. Everyone who is answering that, what is that? Rho GH or MGH. Yeah. That is for the cases that we tell. But when the definition comes into picture, the definition is what? Change in potential energy is equal to, not consider students, that is for a case also. It is a case where you take, it is basically minus of work done by what? What, students? Work done by conservative force. Got it? This is a formula that you need to remember, students. Always remember this. See, whatever you are saying MGH or MGH2 minus MGH1. These are for specific cases that we take into picture. But when you talk about potential energy, yes, when you talk about potential energy, it is what? Change in potential energy we define as what? Minus of work done by conservative force. So always remember, students, what? The potential energy is defined for what? For students, conservative forces. For conservative forces. मतलब देखो, इलेक्ट्रोस्टैटिक फोर्स, ग्रेविटेशनल फोर्स इज कंजर्वेटिव फोर्स, तो उसके लिए पोटेंशियल एनर्जी डिफाइंड है. लेकिन कभी ऐसा सुना है कि फ्रिक्शन के लिए पोटेंशियल एनर्जी है? नहीं ना. तो कभी ये मत सोचना कि अगर sir, why sold we take in? I didn't get you, Ballari students. I didn't get your question. I didn't get your question, students. Ballari students, let me know. What is the question? Yes. See, this is the formula that we get, okay? The change in potential energy is basically the negative of, see, whenever we try to solve the problem, okay, you will be able to understand it very clearly. Don't worry, for time being, understand that change in potential is basically negative of work done by conservative force, okay? you'll be able to understand that negative sign QI. But ಓಕೆನಾ ನಂಗೆ ಅರ್ಥ ಆಗ್ತಿದೆ ಯು ಹ್ಯಾವ್ ಅ ಡೌಟ್ ಯಾಕೆ ಅಲ್ಲಿ ನೆಗೆಟಿವ್ ಸೈನ್ ಬಂತು ಬಗ್ಗೆ ಯಾಕೆ ಬಂತು ಅರ್ಥ ಆಗ್ತದೆ ಓಕೆನಾ ಸದ್ಯಕ್ಕೆ remember that change in potential energy is equal to minus work done by conservative force. Now if that is the case, this change in potential as delta U is equal to minus work done by conservative. Okay, just a second. Okay, students, is it clear now? Is my voice clear? Very good, very nice. Is my voice clear now? Is it clear? Why no one is replying today? What is happening? Krishna 3T, everyone is what? Is tired or what? Is there an issue? Are you able to understand the class or not? Let me know. See, I'm making an effort over here to try to make sure that you understand. So please make sure that, yeah. Okay, Sweetie, very good. Yes. JNV students, make sure that there is a reply from your side, okay? Otherwise, it's not clear whether you are able to understand or not. And later you're going to give feedback, and the feedback, you will give it as you didn't understand the class. So see, I'm asking you again and again. So make sure that you tell me whether you have understood it or not. Okay. So yeah. So we came to know that the potential energy is what? Negative of work done by the conservative force. Okay. So don't worry, students. We'll slowly understand this. Okay. We'll slowly understand this. Yes. We'll slowly understand this. Okay. Now, so always remember this, students. Always remember this. Please note it down. Please note it down. Always remember that what? For a non-conservative force, for a non-conservative force, yes, potential energy, what? Okay, I'll write it in another color. Potential energy is what? Not defined. Is not defined. So please remember this. Potential energy is always defined for what? Is always defined for which case, students? Harish, very good. Yes. So it is defined for what, students? Only for conservative forces. Is it clear? Very nice. Very good. Now, students, as I said, I told you that this changing potential energy is equal to minus work done. So can I write this change in potential energy as what? Potential energy final minus potential energy initial is equal to minus of work done by conservative force. Can I write this? Can I write this, students? Yes. Yes or no? Very good. Very nice. Now since see, Badari students, you asked the doubt, right? Yes or no? Ki minus Q aaya. Yes or no? Now let us try to take a feel of it. Now over here, let me take two surfaces. Okay, there are two surfaces over here. Now in the surface I have kept, okay, what I'm doing is there is this ground reference as ground. Okay, just a second, let me take a ground over. This is my ground. Okay, this is my ground. Now what will I do is I'll keep the object of mass m once at a height h1 and once at a height m at h2. Okay, this is h2. Yes or no? Now students, if I'm going to keep the masses from what? M1 from height h1 and h2, then students, can anyone tell me what is the initial potential energy and the final potential energy? What is the initial potential energy and final potential energy? Yes, very good. You already know that, yes or no? Since you're lifting from what? The object from ground to h1, and also you're if you're lifting from ground to what? h2. You know that the initial what? Potential energy comes out to be what, students? Mg h1, and the final potential energy comes out to be Mg h2. Very good. That is nice. Now you know that delta U is equal to UF minus UI, and you get what? UF as what, students? Mg h2 minus Mg h1. सही है? Delta U. This is good. Till here it's very good. Yes or no? Yes. Very good. You get this as what? Mg into h2 minus h1. Yes. Very good. Now I told you that delta U is equal to minus what? Minus of work done by conservative force. Now students, can I find it out, the work done by conservative force over here? Now the force that is acting over here, if this is ground, this is a surface, this is the h1, and there is this another m, and this is h2. Now students, which is the force that is acting over here? Let me know. Which is the force that is acting over here? If this is ground, let me know. Is there yes, very good. That is the gravitational force. Very good. That is the conservative force over here. So work done by conservative force over here is what, students? Can anyone tell me? See, over here you know that there is this gravitational force that is acting, and the displacement that is acting over here, like क्या हुआ? मैंने पहले h1 में रखा, फिर h2 पे रखा, तो displacement h2 minus h1 है ना? Yes or no? This is the displacement, isn't it? This is the displacement, students. Parth, very good, very nice. Yes or no? Yes. Others, let me know in the chat. देखो क्या हुआ, मैंने पहले h1 में रखा यहाँ, ठीक है, ये h1 है, yes or no? वेरी नाइस. एंड फिर मैंने कहा रखा? h2 पे रखा, तो मेरा डिस्प्लेसमेंट ये है ना, बेसिकली दिस इज माय डिस्प्लेसमेंट, है कि नहीं? देखो पहले मैंने क्या रखा? h1 इक्वल टू 10 पे रखा, फिर h2 इक्वल टू 20 पे रखा, तो ये क्या? ये 10 है ना, ये डिस्प्लेसमेंट 10 है ना? यस और नो? Yes or no, students? Let me know. Yes, very good. Now, if that is a case, can I write? You know that work done कहाँ हो रहा है? एक हो रहा है नीचे, एक हो रहा है ऊपर. Yes or no? Yes or no, students? कि work done हो रहा है नीचे. Yes. देखो, जो फोर्स लग रहा है वो है mg नीचे, जो डिस्प्लेसमेंट हो रहा है s ऊपर है, जो डिस्प्लेसमेंट s क्या है? h2 minus h1. So can I write the work done as minus f into s? Yes or no? And can I write work done as minus f is what? Mg, s is h2 minus h1. Yes or no, students? ये है हमें. अब मुझे ये बताओ, आपको जो फॉर्मूला था वो डेल्टा u इज इक्वल टू माइनस वर्क डन बाय ये था. Yes, my work done by conservative force. Now I got delta u as what? I got delta u as what? Mg into h2 minus h1. और ये पहला इक्वेशन था और ये सेकंड इक्वेशन था. मुझे इस सेकंड वर्क डन बाय सेकंड, जो सेकंड इक्वेशन हो को इक्वल करना है डेल्टा u को, तो मुझे क्या करना पड़ेगा? If see, you know that over here when you compare the first and the second equation, mg same है, h2 same है, h1 same है, but there is a negative sign. So if I want to do the work done by the conservative same, so what should I do? It should be same. ना ऐसा नहीं. देखो इसको मैं इक्वल करना चाहता हूँ, यहाँ एक ये यहाँ पॉजिटिव है, यहाँ नेगेटिव है, तो what should I do? Can I multiply the work done? If I multiply the work done is equal to minus what? Minus mg into h2 minus h1 multiply by नेगेटिव साइन. अगर मैंने इसको नेगेटिव साइन किया तो क्या हो जाएगा? माइनस वर्क डन इज इक्वल टू mg what? h2 minus h1 हो जाएगा ना? yes or no? let me know. सही है? yes or no? now students, you know that this is what? ये क्या था आपके पास? ये था डेल्टा u ना, ये था आपके पास डेल्टा u. yes or no? तो ये क्या हो गया, डेल्टा यू हो गया. So I'll get delta U as minus work done by the conservative. है कि नहीं? Ballari students, did you get it? Why we get a negative sign over here? Yes or no? I'll go through it again, but did you understand it or not? Let me know. Let me know. Ballari students, yes. Path, haha, yes. Pakka, pakka. I'll do it. I'll do it. Let me know, YouTube students. Let me know. Yes, Harish, very good. But theta over here, see. Yes, very good. Sweetie, let me know, Harshada. See, as I said, I'll go through again everything. Okay, you need to understand. As I said, yes, let's do one thing. In the meantime, okay, as I'm explaining, please answer the NPS poll. Okay, please answer the NPS poll. I'm launching the NPS poll also. Now, talking about the potential energy. As I said, in physics, the potential energy is not defined. So what is defined? The defined is change in potential energy. They told that change in potential energy is equal to what? Minus work done by the conservative force. ये उन्होंने बताया है कि नहीं? Now students, as I said, see, you can write the equation as delta U is equal to minus work done by conservative force. And I told you that the work done or the potential energy is defined for what? Is not defined for non-conservative force. It's only defined for conservative force. Yes, you know which is a conservative force, which is a non-conservative force. Now I took a specific case where I took a ground and I took two surfaces. Okay, this is surface 1 and this is surface 2. Now what did I do is ground से मैं निकाल के surface 1 पे रखा, फिर से मैंने क्या किया, उसको surface 2 पे रखा. ठीक है, कौन सी मास है हमको, तो मैंने बोला कि इसका हाइट h1 है फ्रॉम ग्राउंड, इसका हाइट h2 है फ्रॉम ग्राउंड. सही है, यहाँ तक सही है. अब मैंने बोला क्या बोला कि जो पोटेंशियल एनर्जी है इनिशियल और पोटेंशियल एनर्जी फाइनल है उसको फाइंड आउट करो. And you told me that potential energy initial is this, potential energy final is this. Yes or no? Yes, you told these things. Yes or no, students? And you got to know that initial और final को minus करोगे तो ये आ जाएगा. Yes, that is mgh2 minus h1. Now what we did was we wanted to find the work done. The work done by the conservative force is what? Minus fs. Yes or no? क्यों अगर मैंने इसके ऊपर मैंने एफबीडी डाला, देखो इसका जो डिस्प्लेसमेंट हो रहा है ये इधर है, ये डिस्प्लेसमेंट है, और जो फोर्स लग रहा है वो इधर है, वो क्या है, mg है. तो इसका एंगल क्या होगा, इसका एंगल थीटा इज इक्वल टू 180 डिग्री होगा ना. तो आपको पता है वर्क डन इज एफएस कॉस थीटा, तो माइनस एफएस आएगा, फिर आपको आया वर्क डन इज इक्वल टू माइनस mg h2 minus h1. Now I wanted to make sure that delta u and work done by conservative force is same. Now you got to know that this term is same, but there's a negative sign. In order to do that, what? See, you know that there's a negative sign and this term is what? Delta u. So what you did was multiply with minus what? Minus sign, negative sign. That is how you got delta u equal to minus omega c. Sorry, work done, sorry, not omega c, work done by conservative force. Yes or no, students? Did you get it or not? Let me know in the chat. Yes. Very good. Okay. Yes. Clear. Very nice. Now, if that is the case, students, I'm going to give a Homo question for you guys. Okay. Very good. So I guess everyone has answered the NPS. Okay. Everyone has answered the NPS. So yes, I'm ending the poll. Very nice. Now, if that is the case, students, let's do one thing. Just a second. Now, here is a question for you guys. In order to try it, okay, you need to try it. You make sure that you are trying it, and this is a Homo question. The question says, okay, this is a conceptual question. This is a conceptual question. Okay. Suppose it is saying that, okay, this is a conceptual question, don't worry. It's very easy question. They're saying that the force is given as 2x and potential energy P is potential energy at x equal to 1 is 10 joule, okay, then they want find the potential energy, okay, at x equal to 2. Okay, since we have 5 more minutes, students, can you try this once? I'll give the hint how to try this. Okay, so you know that work done by final minus work done by initial is what? Minus work done by the conservative force. Yes or no? Now apply it. Okay, that is the answer. You're saying that is the answer, student, part. No, part, that is not the answer. Please check it. Please check it. So this is the formula you need to use. But over here, you know that see, work done can be used as a formula. What is the formula? Integration of fx dx. Yes or no? Use this formula. And it is given directly that what? U initially is what? 10 joule. ये डायरेक्टली दिया है, ये आपको फाइंड आउट करना है यू फाइनल, बस आप फाइंड आउट करो। तो एक्स का लिमिट क्या है? एक्स इक्वल टू 1 to 2, बस काम खत्म। ऐसा नो स्टूडेंट, लेट मी नो व्हाट इज आंसर नाउ, लेट मी नो। अच्छा, no 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 no, 20 is not the right answer. Path, check the answer again. Others, let me know in the chat. Ballari, Chitradurga, Davangere students, are you able to understand it or not? Let me know. Harish, okay. Harish, your question is minus y minus fs in this previous problem, right? In this previous here, right? Here, as I said, theta is 180 degree, Harish. Why? Because see over here, this what angle between work the force and the displacement is what? That is cos theta, right? That is theta. That theta is what? 180 degree. That is why. Is it clear, Harish? Let me know. Very nice. Others, did you do the problem? Let me know in the chat. ये बहुत easy है. Should I solve it? Should I solve it? Let me know. Let me know in the chat. Okay, others. Dekho. Very nice. Okay, sweet. Okay. Okay, let us check the answer. See, the thing is, they are given the force to be 2x. This is your force. Okay. And what else, students? Let's check the answer. Okay. And they are given the potential energy at x equal to 1. इसका मतलब क्या है? जो initial potential energy है वो दिया है 10 joule. They need to find the potential energy at x equal to 2. इसका मतलब कि final potential energy हमें find करना है, ठीक है? We have the formula what uf minus ui equal to minus work done by the conservative force. Yes. Now you know that work done is equal to integration of, इन्होंने दिया f is equal to 2x. तो कौन सा फॉर्मूला यूज कर सकते हैं? We can use fx dx. Yes or no? ये यूज कर सकते हैं स्वीटी. Yes or no, sweetie? Did you understand the question? Yes, very good. Now you know that there is this limit from x equal to 1 to x equal to 2. So can I write the limit from 1 to 2? And can I write work done as what? 1 to 2? What, students? 2x. Yes or no? Yes. 2x dx. From here, work done would be what? 1 to 2. Okay, it will be, sorry, I'll do the integration. That will be 2x square by 2, 1 to 2. Yes or no? And it will be 2 cancels out. If I write it work done, that is 2 square 4 minus 1, which is equal to 3. So work done by the conservative came to be 3. Now you have the work done by final force, the final potential energy. You need to find it out. Final potential energy, initial potential energy is what? 10 over here, that is 10, which is equal to minus potential energy is what? 3 over here minus 3. And if I write uf is equal to minus 3 plus 10, and you get the final potential energy to be what? 7 joules. Yes? Did you get it, students? Yes, very good. This was your answer. Let me know in the chat. Yes? Easy but tricky. Yes. Very good, students. So this was a homework, students. So let's do one thing. Your homework is basically homework is we had to touch around gravitational potential energy. Don't worry, we'll talk about it in the next class. Homework is you need to try to understand what is potential energy and solve simple numericals based on it. Okay, simple numericals. You'll get it in your what NCRT. Okay, you'll get it in an NCRT. Try solving. Okay. So students, that's all for today. Before ending our today's session, students, let us try to summarize. The first thing what we did, you remember what we did? Let me know in the chat. We recalled everything we have talked about. Yes, about what? About work. Yes or no? Because we are going to talk about energy. Already we have talked about energy now. Because we try to what relate with kinetic energy. We already talked about potential energy now. And also now we talked about what? Numericals after that. Yes or no? Numericals. And we talked about what? Potential energy. In potential energy, what we came to know that here we always talked about what? We always talk about change in potential energy. That is delta U is equal to minus the work done by the conservative force. Yes? Yes or no? And we also solved the numericals based on this. Yes or no, students? In tomorrow's class, we are going to continue based on potential energy. And in this week or in coming week, our work power energy will be complete. Yes, PE and work done. Potential energy and work done. Yes, very good. So students, thank you for attending. If you have any doubt, I'm over here. You can tell me what if you have any doubt. Okay. YouTube live students, thank you for attending. Take care. Bye bye. See ya. Have a nice day. Okay. Have a nice dream also. Students, also